Good afternoon. Welcome to our presentation. We are Group 5. We're excited to share our analysis and findings in terms of conservation, reuse, architecture, sustainability, and heritage in Vertigo, the architecture faculty in Eindhoven.
The former T-Hawk building, built in 1963, was the chemistry faculty of the university. In 1998, a competition brief opened to transform it and make a new educational building that could host the architecture faculty and be the new face of the campus. Several architects entered the competition, but finally, the Dirrix office won with its innovative proposal.
Our impact assessment focuses on the layer of a space plan, the layout of the spaces and the elements, tangible or intangible, that configure this arrangement, such as walls, ceilings, uses, atmospheres. We will assess the purpose of this layout, seeing how they change with respect to the original situation in the different domains of CRUS.
For the conservation domain, I've chosen durability as the main indicator, to see the impact in the use of new materials and his relation to the space plan, analyzing the partition walls, ceilings, floors, and the main stairs. By creating a list of the used materials and their lifespan, an estimated condition assessment of the building was made, using the NEN 2767 and the MDCS Damage Atlas. Each building component is shown with the data of the before and the after side by side. Partition walls were replaced, and in addition, they added a new type of walls made of glass. Ceilings changed in order to improve the acoustic of the spaces. Floors were recast with the same materials that they already had, and the main stairs, which was the only element preserved, had a change on his finishes. Different factors of durability were used to assess the impact per building component, showing the total impact of the redesign. There has been an overall improvement in almost all the factors. The use of high-quality materials and better technical aspects show an effort to create a better spatial configuration. However, it could have been possible to preserve more parts of the previous building.
For the domain of reuse, 3 indicators will be used to analyze the spatial functionality of the building: vitality, how diverse are the uses of the spaces; effectiveness, the role and potential of spaces in a network measured by different centralities; and efficiency, the accessibility of spaces, how far they are from the outside world. For the analysis, the data is collected using the floor plans of the before and after situations. The spaces are classified and analyzed using Grasshopper and Excel, and then computed with Gephi. The subsequent statistical analysis would determine the impact. Through the process, we are able to understand the functionality of the building thanks to different graphs. Finally, the impact assessment. In vitality, analyzed by count and area, we see a slight decrease, which impact is considered neutral. In effectiveness, the correlation leads us to a minor adverse impact due to a minor decrease in most centrality measures. In efficiency, the average depth suffers a high increase, and thus the impact is considered major adverse.
For the architecture domain, the indicators chosen are dimension and typology as the relationship between size and type of space within the floor plan, atmosphere as an experience through proportions and natural light, and space dialogue or the way rooms interact with each other. The analysis shows an overall increase of open workspace area and decrease of technical rooms. The general atmosphere of this workspace is improved as proportions become more harmonic and light flows through the floor plan. Regarding space dialogue, the floor plan is decompartmentalized, becoming clearer, and interaction between rooms occurs easily, improving the pre-design. The impact is studied by assessing the value of the pre-design and design regarding the indicators and by measuring the compatibility of the design to the previous DNA and context. Results are illustrated in the adapted spiderweb that classifies changes in its subindicator from major beneficial to major adverse.
The code for each aspect was given a different weight. The requirements for each level of impact is shown in the upper part of the table and the final result at the bottom. Both sub-indicators show improvement. Overall, there are less rooms and the ones that exist are bigger. The connections between spaces is now predominantly room to distribution instead of room to room. The final impact of designing the domain sustainability is minor beneficial. The results are shown here. For the first sub-indicator, the walls are divided into categories depending on how difficult it would be to modify them. The total linear meters and percentage of each category was measured, as well as how much space is enclosed in rooms. For the second sub-indicator, connections belong to 2 categories. The total number of each is measured in the graphic on the left, and the ratio between connections and rooms is shown on the right. From the 3 dimensions of sustainability, only the economic aspect is analyzed. The indicator chosen is adaptability, which measures the ability of the building to be changed to meet a new use. 2 sub-indicators help measure this. Internal wall system. Considering porting is a lot of barren walls and small enclosed rooms are not suitable for most uses. Connectivity. Worth measuring because good entrance and egress from rooms guarantee effectiveness.
The elevator core is the most important spatial connector in Vertigo. How have space plan decisions affected connections to the circulation core? What are the impacts on the feeling of connectivity in the Vertigo community? I define connected spaces as those which are within a close proximity to the circulation core. I ranked rooms on a scale of 1 to 4 based on their distance from the circulation core, multiplied the scores by the percentage of total floor plan area occupied, and later tested weighting by the number of rooms. To further validate my findings, I polled students and found that 75% don't feel connected to the upper floors of Vertigo. The impact assessment is neutral. After comparing the data from both the weighted and unweighted data sets, it is clear that the impact of the design decisions made in terms of spatial plan have had an average impact on connectivity when measuring rooms in relation to their proximity to the circulation core. As a team, we found many similarities in our data sets, and even sometimes found indicators, themes, or methods which overlapped. Although there were overlaps in our data, we made sure to stick to our domains so that we could get our specific analysis. It was great to have an entire team to learn from and learn with.
Overall, materials introduced have better quality and longer lifespan. Spatial connection is less effective and efficient. The redesign adapts conveniently to the architect's idea and current use. Adaptability has been improved, and last, connectivity and the sense of community has been somewhat maintained.
Finally, our impact assessment goes as follows. Conservation, major beneficial. Reuse, adverse. Architecture, beneficial. Sustainability, beneficial. And heritage, neutral. Thank you for your time and attention.